All right, today's section is on proving angle relationship. So in 12.5, we did some line segment proofs. Today we're going to do some angle proofs. Now, a lot of the theorems that we learned so far, a lot of them that we used yesterday when we did line segment proofs, also work with angles too. And here's some examples of that. So number one, yesterday we had the definition of congruence, and we were talking about line segments. It works for angles too. So if two angles are congruent, their measures are equal, or if two measures are equal, the angles are congruent. It's an if and only if. It works either direction. Number two, angle addition postulate. Yesterday we had segment addition postulate. It said if you take two line segments and stick them together, the two pieces add up to the whole. Same thing here. In this picture, if I know what this angle is right here, let's say that's 30 degrees, and I know what this angle is right here, let's say that's 60 degrees, I add them up and the whole thing is 90 degrees. I mean, it's a very simple postulate. So if you have, just like yesterday, if you have two line segments stuck together, you can add them up to get the length of the whole one. Today, if you have two angles stuck together, you can add them up to get the whole thing. All right, another good one we've been using a lot and definitely works for angles is the transitive property. If two angles are both congruent to the same third angle, then they're congruent to each other. So if angle A is congruent to angle B, and angle A is also congruent to angle C, then B and C are congruent. Any of the algebraic properties work, addition, multiplication, distributive property, substitution, all those things work. And that's basically how proofs work. It's not like, oh, hey, we're good, we're done with that section, so let's forget that and learn something new. It's like, hey, we learned something, let's add to it. So we're going to keep adding more and more rules and properties and theorems and postulates. It's like a toolbox of possible reasons you can use in proofs. Now, there are a couple theorems we didn't use yesterday with line segments, but we have learned before. This is not new. Remember, we did a whole module on angles. One of the things we learned in that module was the vertical angle theorem. It says that vertical angles are congruent. So, for example, let's say I had this picture right here. We have two different lines crossing, like this. The vertical angles are the pairs of angles opposite each other. So like this one and this one right here that I marked in yellow, those are congruent. Those are vertical angles. But the top and bottom, which I'll mark in purple, it's a little bit hard to see, but the top and bottom angles are also congruent. Then we learned the linear pair postulate. The linear pair postulate says, fix this picture so it's not, oops, that's okay. The linear pair postulate says linear pairs, they aren't congruent, they're supplementary. They add up to 180. So a linear pair, let's just get rid of this and do it in the picture. I can use the same picture actually, but a linear pair are the two angles next to each other. So it might be like angle 1 and 2 right here. Those two angles are not congruent. Angle 2 is small, angle 1 is big. But those two add up to 180. They're supplements. So those are good rules you can use for reasons and angle theorems. If you have, and it doesn't have to be two lines crossing, if you have a line like this anywhere, and then it's split into two angles like this, those two angles, I'll call them 1 and 2 again, that's a linear pair, they add up to 180. So here's some general tips. Starting today, you guys are going to create the entire proof yourself. Yesterday I gave you some fill in the blanks where I did some of the work and asked you to fill in part of it. Today I want you to try writing an entire proof by yourself. So here's some tips. Number one, the first statement is always what was given in the question. Every proof has to start with something. So it's going to say given something. That's your first statement. The reason is given. Now your last statement is the thing you are trying to prove, but it needs its own reason. The reason is never the word proof. I talked a lot about that yesterday. So no matter what, no matter how many proofs we ever do, the reason in a proof will never, ever, ever be the word proof. Number 3, you got your given, you got your proof. You have to get from given to prove connecting using valid if-then statements. You say, okay, well, this was given, that means this, and that means this, and that means this, and eventually you'll get to that thing you're trying to prove. Now, sometimes in an easy proof, it might take 2 or 3 steps. In a harder one, it might take 5 or 6 steps. We don't know. There's no rule that says, oh, once you do 5 steps, you're done. Or once you do 3 steps, you're done. Or 10 steps, you're done. We don't know. You just got to get from given to prove as quickly as possible. And then, of course, you have to give a reason for each statement. We practiced that yesterday, too. So let's try a full proof. Instead of yesterday, I filled in some of the statements and reasons and had you fill in the missing ones. Let's just take a blank 2-column proof, statement, reason, completely blank, and let's do this proof. So we have 3 things. We have some given information, we have something we're asked to prove, and we have a picture. So let's start with the easy stuff. Everybody gets one for free. So for statement number 1, just copy down what was given. Say angle 1 and angle 2 form a linear pair. And measure of angle 1 plus measure of angle 3 equals 180 degrees. Reason, how do I know that's true? That was given in the problem. So those 2 are automatic. If this is a quiz question, that's like me giving you guys free points. Everybody should get those points. So now, the next thing I need to do is find some way to prove that angle 2 is congruent to angle 3. So let's look at the picture and see if we can come up with a plan. So I said angle 1 and angle 2 form a linear pair. Now we just talked about the linear pair postulate. Linear pairs add up to 180. Then I said 1 and 3 also add up to 180. So this one and this one also add up to 180. So whatever 1 is, let's say 1 is 100 degrees, for me to just throw out a number, even though you can't do that in a proof. But let's just so we can get an idea of what we're doing. If angle 1 is 100 degrees, then angle 2 has to be 80 degrees, because they both add up to 180. And angle 3 also has to be 80 degrees, because they both add up to 180. Well, if 2 and 3 are both 80 degrees, they're the same, they're congruent. So I got my plan, I just have to figure out how to say that. So let's start saying some of the things we just said. The first thing I said is that angle 1, we'll say measure of angle 1, plus measure of angle 2 equals 180. The way I know that is because it says in the given information that 1 and 2 are a linear pair, and the linear pair postulate says that linear pairs add up to 180. So my reason is the linear pair postulate. I'll do POST to abbreviate postulate. And again, I've talked to you guys about this before. If you say anything about a linear pair, I'm giving you credit for this. Even if you accidentally called it the linear pair theorem or the linear pair definition, or if you just said because they're a linear pair. If I see the word linear pair in there, you're getting credit for that. All right, so the next thing I need to do is show that 2 and 3 are equal, or 2 and 3 are congruent. So if you look at this right now, what I have is transitive property again, just like yesterday, and I told you guys we use this a lot. I have 2 different things that are both equal to 180 degrees. I have this one here and this one here. If those things are both equal to 180, then they're equal to each other. So let's write that out. Let's write measure of angle 1 plus measure of angle 3, the top one, equals measure of angle 1 plus measure of angle 2. That's the transitive property. I noticed that 2 things were both equal to 180 degrees, so I can make those 2 things equal to each other. All right, take some of this out. I like to make notes while I'm talking, but I don't want them there cluttering up the proof. Okay, step 4. When I look at step 4, what I see is an equation, and I see the same thing on either side of the equation. I have measure of angle 1 plus measure of angle 3 equals measure of angle 1 plus measure of angle 2. I could subtract measure of angle 1 from both sides of the equation and basically cancel them out. If I do that, what I get is measure of angle 3 equals measure of angle 2. Now, what I did, I subtracted from both sides of an equation. That's the subtraction property. That's like I'm going back to our algebraic proofs. All right, we're getting close. One thing I notice here is it's out of order. If you look up here, I want to show that 2 is congruent to 3, and I have 3 is equal to 2. So let's flip it around. Let's say if measure of angle 3 equals measure of angle 2, then measure of angle 2 equals measure of angle 3. We're allowed to flip equations. In fact, we have a name for that. It's called the symmetric property, and that's our reason. Symmetric property. So if you ever want to flip your equation, remember when you're doing it algebraically, it was like if you solve and it says 5 equals x and you wanted to say x equals 5, that's the symmetric property. But it can work with this too. If you have angle 3 equals angle 2 and you wanted to say angle 2 equals angle 3, you can do that by the symmetric property. Okay, there's only one more step. What we have is measures equal, but remember if you look up here, we don't want to say the measures are equal, we want to say the angles are congruent. We want to say angle 2 is congruent to angle 3. Now remember what I told you guys, anytime you're doing this, anytime you're saying, okay, if the measures are equal, then the angles are congruent, or backwards, if the congruents are if the angles are congruent, then the measures are equal. That's the definition of congruence. And that's our last reason. So we are done with our proof. I'll take the extra stuff out. And what we did, we had 6 steps. We took our given information and we proved that angle 2 is congruent to angle 3.